Hello. Today we will discuss about bisection method. By using this method, one can find the solution of a function or the roots of the function. To explain this thing, we are going to take a graphical representation of this. We are assuming we have a function y is equal to f of x, where x is the variable and y denotes the function, the output function. But what will be the nature of the function? This will be different for different types of function. Here we have taken a function which looks, after plotting, it looks something like this. The green car is swinging. Now in this car, somewhere here the value of this function is equal to 0. So here one can find the solution of this function or the root of this function. Now to get this thing, we are going to take two guesses, guess number 1 and guess number 2. So what is there? So guess number 2 will be some numerical value on the x-axis or the x variable, whereas guess number 2 is also on the x-axis, that's mean a variable on this x variable. We are going to put these values, and for this particular curve it is observed that for guess number 1 the function value is negative, whereas for guess number 2 function value is positive. And it's very obvious, if a function goes from positive to negative or negative to positive, somewhere in between there will be a 0 value of this function. So this will be our approximated root or the solution of this function. What we are going to do, we are going to find the average of these two guesses. If I are assuming that guess number 1 as A and guess number 2 as B, so one can write C is equal to A plus of B. So this is the root of this particular function. Now to understand this thing, we'll take a simple example and we'll try to have a calculation for this. So to do this thing, we're going to use a bisection method online calculator. We have taken a function something like this, x square plus of 2x minus of 5. This is equal to 0. Obviously. We need to find for which values of x the function becomes 0. So we are assuming there our first guess A is equal to B and A is equal to 1 and B is equal to 2. So we'll try to find the root of this function within 1 and 2. So for that, what you have to do? First job of this thing, we have to find the function f of x, where x is equal to a. So what will be this thing? So when you are considering x is equal to 1, so this means 1 square means 1 plus 2 into 1, x is equal to 1, 2 into 1 minus of 5. If you have this thing, so this value becomes, this is 3 minus 5. So this is 3 minus of 3. This is less than 0. Now we'll take our second value for f of b, means when x is equal to b. So if x is equal to b, so this becomes 2 square, that's means 4, plus 2 into 2, this is also 4, and minus of 5. Now this is 8 plus minus 5. 8 minus 5 gives you. Now I have done a mistake. You just check this one. This will be minus of 2. This will be minus of 2 less than 0. So 3 minus 5. This is minus 2. But the most important part is that f of a, the value of f of a is less than 0, whereas f of b is greater than 0. So your function must be within a and b, within the interval of a and b. So what will be the value? So we'll take the average of this one. So average of this one is given by a plus b. That means 1 plus 2 divided by 2. So 3 by 2, it is 1.5. So our x2, or this can be written as a, this is b, and this is c. So this is the root of this. But the problem is, you really don't know whether this is the exact value of this thing. So you have to have a trial guess for this one. So to have a better result from this, So every time you will not get an exact value of 1.5. It may be 1.65 or it may be 1.45. We really don't know this one, whether this is exactly 1.5 or not. So to check this thing, we'll go for some number of steps. We'll go for iterations. So what we're going to do? So to do these things, we're going to follow this flowchart. Just come to this point. So we'll start. I will enter the function and guess A and B, the initial two guesses will be. Then we'll find, so obviously guess A and B should be something like this. F of A and F of B must have a two different value, either less than 0 and greater than 0. This condition must be satisfied. When you have this one, you will get C. So what is C? A plus B by 2. Now, if when you have A plus B by 2, so you will find what is the function at x equal to C. Now you have to check whether that function f of C is greater than 0. Then we have to consider, if this is greater than 0, then you have to consider B is equal to C. If it is not, then one can think about this is A is equal to C. And you need to go for some number of steps to get that accuracy. The concept is something like this, that if you have this function, so here it becomes negative, it becomes positive, these two values. So in between these two, we have the root of this one. So initial guess and initial FC value. Now this is negative, this is positive. So in simple way, one can find, again we can go for some higher approximation. We'll consider, now this is FA and this becomes F of B. This is negative, this is positive. So your root must lie within these two values. And if this is positive and this is negative, so obviously we need to neglect this one because both sides becomes negative. So now our root will belong in between negative and positive. So the calculation of FC becomes very, very important. If it is greater than 0 and if it is less than 0, so we have our calculation. So if this is greater than 0, so we need to consider the negative side. So root will be between negative and positive. And again, if this is less than 0, this is negative. So you need to think about negative and positive in between. So you need to go for this thing some number of times to get that exact value of this function. So now come to this point. Now in this case, what we have done, we have the function, we have the guesses, initial guesses, but we have considered some error. So what is the error value? So error value will be F of C. So what is this F of C? So now we have to check whether the F of C, so if you are going along F of A, say this is positive, and what you have got, F of A is negative. So obviously you don't need to think about the F of B. So now your root will be within A and C. So after number of iterations, so number of positive and negative function value, we will have to go for the bisection, divide this thing, and you will get the value of the exact value of this root. Now for a certain value of C, the F of C will be lesser than this error, lesser than this error. So then we will consider we are very close to the exact value, we are very close to the root. Now check this thing. So first we have guesses 1 and 2, we have got the C value, we have got the bisected value, and we are able to calculate what is F of C or what is F of x2. Okay. Now comes, now in this case, F of A becomes negative and this becomes positive. So obviously our root between, this is also positive, FC is also positive. So just let me just note one. So F of A, F of B. Again it comes to F of C. Now see, these values are in between, this is negative, this is positive, and this is also positive. So your root cannot be within B and C, rather it will be within A and C. Our next step will be calculated within 1 and C. So A and C. So this is A and now it becomes B. Now again you have to go for this thing A and B in between A and B. So you have to check it for f of C. Then again calculated it whether this is in between two FC values. Go for the iteration, and at the end of this, so after go for number of iteration, 15 iteration, we have got the error value, which is 0.000 for tetra 018. So this is very close to now our root value, which is C values now. After iteration, C values. Okay, thank you.